So I'm seeing a bunch of people in the Etherpad who are not quite in the call yet, or just maybe one or two now. So we'll wait another couple seconds. Good morning, Bianca. Thanks for joining us. Good morning, Peter. Thanks for coming.
Hi.
It's good to see you too. We're going to wait just another couple minutes for people to show up and then we'll get started. And I'll drop the Etherpad in the chat one more time. Yes, I can hear you. So I think we're waiting for a couple more people and then also hopefully Joey Lee. But let's see. We'll wait one more minute and then we'll get started. For those of you who are already here and have study groups, while we're waiting, under line 37, please add progress on your goal from last week. And if you want to be reminded what your goal from last week was, they are on way down in the Etherpad. Wow, last week's meeting was long. Okay, so under line 206. So for those who added goals for their study groups last week, underline 206 way down at the bottom of the Etherpad, just update us a bit about your goal or progress on your goal for this week. And we'll do that for 2 minutes and then we'll get started. Okay, so it looks like we have lots of goals updated in the Etherpad, which is great. And I just want to point out and highlight one goal under line 44. Aurelia, do you want to verbalize this particular goal and remind people why it's important?
Oh yeah. So when you force the study group resource, it doesn't allow you to have issues by default. So you have to go in your settings, and it's a checkbox at the top to enable issues. And that's part of, if you read the orientation guide, it's part of how you set up events. So you have like a comments chain that comes from issues and is linked to your posts on your website for events. So in order to make events, you need to have issues. And I also like it because I can chat with you if you enable issues. And if you don't enable them, then I have to go into a commit and be super creepy and be like, hey, I'm going to comment on your commit, like a code review, when really I just want to say hi. But it's just kind of creepier when it's a public issue. So don't make me be creepy, please enable issues.
I think the other key thing, and that is absolutely right, don't make it really be creepy. But I think the other point is that once you have a group, you can have group discussions about your study group in those issues. So it's really, really important. Participants can comment on upcoming sessions. You can have people volunteering to help you run upcoming sessions. So it's super, super important. So let's jump into the rest of the program today, and today is our Open Science 101 section, and I'm actually, and so we're going to start on line 47, and we have a bunch of open science learning resources. You guys all should have read or at least skimmed or know that it exists. Section 4 of the study group onboarding guide has our little rundown of Open Science 101, so that's there for background, and hopefully you've taken a look at it. If not, I urge you to do so. And we're lucky today in that we have a couple people who are guests on the call who can talk about some amazing open science tools. And actually, I'm just going to jump right down to line 51 because Peter Cracker is here from Open Knowledge Maps. And I want to invite him to talk about the tool. I put a 3-point summary, which I hope is mostly correct, under line 51, but I want to invite Peter to talk about this amazing tool. And what's great is that they've just created a study group lesson, which this is an excellent sort of fun first study group meeting if you're looking for something to do as a kickoff for your study group. This is a really amazing tool and a great way to get an overview of a field. And so this lesson is an excellent study group starter, sort of icebreaker experiment. So Peter, do you want to just talk more about the tool and maybe just explain it for the group?
Yeah, sure. Well, first of all, thanks for the nice words. And I think you summarized it pretty well. So Open Knowledge Maps was really born out of the frustration with the discovery tools that we have at the moment for scientific research. And what we're trying to do is to give you a visual overview of research topics and research fields. Basically what we're creating are knowledge maps based on, well, at the moment we're offering connections to the Directory of Open Access Journals and to PubMed. And the idea is really that you have an instant idea of what the main topics are that are being discussed within your search, and what are the most or what are relevant papers that are connected to each topic. And what we did for the lesson was basically we've also developed a workshop concept which we've run at MozFest and OpenCon and other conferences, and we've turned that workshop concept into a lesson. So basically the idea is that you try to get an overview of a research field that you have little or no knowledge about. And we've tried to also incorporate videos and a group discussion in order to make it an interactive experience and something that tries to recreate what happens in our workshops.
Great. Are there any questions for Peter about the tool? Peter, if you have screen share, you're welcome to show a little demo. Do you know how to screen share on video? It's usually right on the lower bar. Is that something that you'd be willing to do real quick? Show a demo of Open Knowledge Maps?
Yeah, sure. Let me just try and figure out how it works. Oh yeah.
And I should say also that Peter did a great session at MozFest, which is Mozilla's annual festival of the internet in London. and that was in November, and he did a great session and workshop on open knowledge maps, and that's where I got the idea that it would make a great study group activity.
Yeah, I think also that it really like we have this sort of the same ideas as Mozilla, because we really want to provide an open science resource in the purest sense of the word. So our code is open, or our content is open, and we also try to keep an open process. So you will see in the lesson that we've also included an Etherpad, like we always do at the workshops. So you can always give feedback there, and we will try to answer. We might not be able to do it during your actual lesson, but we will try to get to it afterwards. So we can really have an interaction, because we try to involve our users into the development process. So feedback is very valuable.
So there's, okay, so go ahead and see if
I'm not very good at
okay, all right.
Let me try. Which icon is it?
It's the one that looks like a little, it's like a square with a little arrow in it, a little right pointing triangle in it, yeah.
Okay.
And then it should give you an option. Okay.
Can you see it now?
Yes, we can.
Okay, very good. So the idea is, so this is the interface that we have now. Up here you can select which resource you want to use. So you can either use DOHA, which has about 2.3 million articles from a wide range of disciplines, and then PubMed, which is of course the big biomed resource, which has I think 95% of the English language literature on biomedical studies, but also related areas. And then you can type in your area of interest, say you're interested in the Internet of Things. And what we do then is that we get the 100 most relevant papers from DOHA, so what they determine to be relevant, also what you would get as a result if you search from their website. But instead of just presenting the list-based interface, we have got this bubble visualization, and you can see that the keywords indicate the different subtopics. So for example here, wireless technologies, sensing reliability, and some protocol sensors. And what we're also trying to do is to group the bubbles in a way that subtopics that are related are actually closer to each other. So for example, well, okay, I'm not that fluent in the Internet of Things, maybe not the best start here, but maybe the smart grid here is related to the networks and ubiquitous computing and things like that. And then you can zoom into the bubbles, and you can inspect the resources. And once you found a resource that's still interesting to you, you can also preview the PDF right in the interface. And that actually is not a preview, but you can read the full PDF. And since we also really want to make this into a collaborative interface for discovery, we've, as a first step, we've integrated hypothesis. And if you log in here, you can make annotations, and yeah, I need to be logged in to do that. But you can create annotations and then share these annotations either just with yourself privately or with the whole world. So this is a first step onto collaborative annotation process.
Great. I think there's a question which you may have answered under line 55.
It's for the first demo. Do you have any questions?
There's a question which you may have answered under line 55, but does that, Madeline, you asked that question, do you feel like the demo answered that question, or would you like a bit more detail?
Yeah, so just to confirm, so you're using the keywords that the papers have to group them into these bubbles?
Well, basically we're using whatever we can get as the metadata. So we're using title, abstract, authors, and keywords. And we're using that to create a big co-word occurrence matrix. And on top of that, we do clustering and ordination and things like that. Okay, so that's what's happened where in the 15 seconds or so that you have to wait. So we're doing it always live, unless two people search on the same day for the same thing. So this will be also important then for the lesson because you will be searching sort of for similar topics, so you don't have always to wait for 15 seconds.
Great. Thank you so much, Peter. I know you're busy, so if you have to jump from the call, we understand, but thanks so much for demoing that. And it doesn't look like there's any other questions right now. Let's see, what else?
Thanks. So if you have any questions, just hit me up on Twitter or anywhere, or in the Etherpad. Yeah, and have a good car.
Great. Thank you, Peter. Bye.
Bye.
So next up, I wanted to invite Madeline, who's here on the call, to talk about her projects. And I believe there's a link underline. Yes. Madeline, do you want to just give us a little bit of background on Phage Parser?
Sure, yeah. So this is a project that my supervisor started up and I've now taken over, and we're trying to annotate CRISPR systems. So a lot of people are interested in CRISPR. There are a lot of organisms, bacteria that have CRISPR systems, and people typically have like a model CRISPR that they study in the lab, and so we wanted to make it easier to find out stuff about CRISPR systems that people maybe have not studied as well. Kind of just using algorithmic ways of trying to process the information that might be available about these systems. So what we've done so far is a lot of people have worked on a series of scripts that will do some kind of scientific analysis on some part of the data. And we also we're starting to work on a database backend. Sounds like somebody is maybe not muted.
Oh yeah, if you are typing, it's best if you can mute.
And we kind of are aiming this at people studying CRISPR systems, but we imagine that it could be useful for really anybody who's interested, and who's just lay people as well. And so that's pretty much all I have to say about that. Question: what is CRISPR? Excellent question. CRISPR is an immune system that bacteria and archaea can have, and it was kind of discovered partially in the 70s and then kind of rediscovered in 2005 what it actually does. And since then there's been kind of an explosion of technology related to CRISPR. So how it works is kind of analogous to our adaptive immune system, where we make antibodies that will target an infection you've already had. So let's say you get chickenpox, you make antibodies, and then you no longer have chickenpox the next time the virus tries to attack you. And bacteria can do something kind of analogous when they are attacked by a virus. If they have this system, they can take a piece of the virus DNA and stick it in their own genome. So they have this like list of virus DNA pieces that are from bad viruses. And then the next time that virus attacks, they kind of compare these sequences that they've grabbed with the virus sequence, and then if it matches, then they cut it with an enzyme. And the way this is being put into technology is that instead of having virus sequences match, if you just make that sequence anything you want to cut, then you can cut very accurately wherever you want to in DNA, basically. So a lot of people are interested in it for that reason, but I'm also more interested in it for the kind of natural, biological reason, like how is it being used in natural populations.
Thanks. I have another question. So how have you gotten contribution, or what makes this, what's been the open science part of this project, other than it being a tool that's openly available? Like, how have you worked on this with others? Does that make sense?
Yeah, so I mean, as far as it being a tool, it's not exactly useful yet. So the open part of it, I would say, is more on the collaboration end. And I think being on the Mozilla projects platform has been like the sole source of contributors. And I've taken it to a few code sprints that Mozilla has organized, and so that's kind of been the source of most of my contributors. And the way we've tried to break it up is to kind of make each scientific chunk a separate kind of subtask, and then people can work on a script that does that thing. So most of those things have been done by contributors.
Awesome. If you have any questions for Madeline, I encourage you to put them under line 62, and she can answer them there. The next little set of things I wanted to talk about, are back up at the top of this section. A couple of resources to mention, and some of these were mentioned in the study group guide for today. Section 4, but I just wanted to point out that we do have this kind of amazing reproducible quantitative methods course that our former fellow Christy Balhai, who worked with us last year, created, and it's a great resource for. It's actually an instructor guide for an entire course that basically teaches you how to take a data set and go through the process of analysis and actually potentially submitting something for publication collaboratively, like with a group of people. So it's basically a collaborative working, almost like practice course. And it also includes some info on analysis in R and thinking about co-authoring papers and tools to use to do that. And I think Christy is also really interested in, and also how to really well document your code and your work. And Christy, of course, is also really interested in gray data, reusing data that's already out there that has a lot of potential but isn't really yet hasn't been well used. So if you're looking for some a sort of structure for your study group as you get started, check out this course. The instructor guide actually sort of steps out almost the full scope of lessons. So you could potentially do this over the course of a semester with your study group if you wanted an activity to start with. And again, there's a link there on line 50. The other thing to note on line 51 are the open data training materials, which Mozilla has under production right now. And if you go to that GitHub link, you'll see that there are both primers and instructor guides. And I think we only have a couple primers up now and one instructor guide, but this is a whole collection of resources on data sharing, opening your data, using other people's data, basically getting the maximum impact out of any available data possible. And so we welcome you to check out those resources and look at them, and there may be things in there, particularly the instructor guide for primer 1, sort of lesson 1, which is sort of why open data. That could be a fun first session for a study group as well. The other thing that I wanted to note there on line 52 is just a little bit, I know one of the, and we'll talk about challenges and barriers to open science and open science practice soon, but one of the sort of difficulties in practicing open science is that open science activities aren't always valued by an institution. So if you're in academia and you're hoping to eventually get a tenure track position and sort of secure your career, some of the things that are valued for tenure and promotion aren't necessarily, don't take open science into account and don't take sort of the changing face of research into account. And so there is a project on reevaluating the standards of tenure and promotion to bring them more in line, or at least have them take into account some really important open science activities. So check that out, that's on line 52. And I think that brings us to the end of our open science tools, learning resources and tools section. Although I do see that Bianca Kramer has added some things under line 67. have a cool tool or resource for open science, tell us about us here. Bianca, do you want to verbalize just one or two of these?
Sure, let me unmute. Can you hear me?
Yes.
Okay. Well, the second one, the database with our tools that we've been collecting for about 2 years now, I collected already last week. But maybe the first one, the Wheel of Open Science Practices, that's really something that we've been working on, my colleague and me, over the last 6 months, gathering these at workshops that we do. And the goal basically is to show the variety of open science practices, especially now in the Netherlands. They're working on a national plan on open science, which is very good, but it's also very much focused on open access and open data. And we really want to stress that open science is broader and it's more than that. So let's see if I can share the screen. Which icon was that again? This one?
It is the little button with the, it looks like a play symbol in it.
See that?
Yeah, I think it's just coming up. Great, there it is.
So this is really, it's about 65 open science practices for discovery, analysis, writing, publication, outreach, and assessment. And it's really a broad variety. So you can click that. And it's we mostly made that for inspiration and to discuss with researchers for study groups and really get across the wide and breadth of open science. I've lost. Yeah. I think that's it.
Okay, great. Thank you for showing that. I think Aurelia, you dropped something in on line 70. Do you want to just talk really quickly about that?
Sure. Sorry, my internet is kind of being weird, so I'm not sure when we will be heard for long. But why open research is just a really nice site that you can share with people about open science and just general open practices if they have any questions about it. And it sort of walks you through kind of a dialogue about that and some resources.
Great. Thanks so much for contributing that. And everyone, I urge you to check out all the links that people have added under line 67 and add your own if you'd like. So we're going to move on, and we have some special guests today, Bruno Vieira and Joey Lee. I believe Joey is here also, to talk about, and Joey is a past Mozilla Fellow for Science, and Bruno is a current Fellow for Science, and just wanted them to talk about open science and stuff that they're excited about, activities and projects that they're into. So we'll start with Bruno. Go ahead.
Thank you. So I'm finishing a PhD in bioinformatics in London, and we try to do everything open, and we develop a few tools in our lab. And during my PhD, I was also doing some JavaScript, some Node.js, and so I started a open source community called BioNode, try to bring more Node.js into bioinformatics, because I think there's a lot of potential in using all the modularity and all the tools available in the Node.js ecosystem and all the best practice, and also there's also cool stuff you can do with Node.js things in terms of real-time analysis, and which I think could be very useful to try to reduce the computational cost and the space cost of some of our analysis. So BioNode is kind of more of a leading edge, trying to bring some new things into bioinformatics. But for my PhD, I'm studying genetic diversity in insects. And so I reuse a lot of existing open source tools, and I mostly end up building a lot of pipelines. So I end up using Bash, Python, R, and sometimes we have a lot of issues trying to get all these tools working on several machines. So reproducibility is a big issue. And so I've been exploring all these tools, Docker containers, virtual machines, things like that. And I think I might have figured out how to get all these things to work and try to, because it's very difficult. Even even if you use all these reproducible tools, it's very hard to make sure that it will be future-proof and that it will work in a year or two. So I'm actually trying to put this down as a blog post. So I have the link of the graph there. It's not done yet. And it's the first part where I expose the problem, and then the second part will be a practical example where I show you how you can use tools, mostly Nix, which is a functional package manager. So basically, it allows you to install software in a deterministic way, and so it doesn't rely on anything on the host operating system. So everything is nested and linked inside a folder. So it ends up being kind of like Docker container, so without any layer. So it's just a folder in your Linux, and everything is linked inside of it together. So you can just then share that folder to another machine, and as long as the architecture is the same, it should just work. So I'm finishing also my first PhD paper, and most of the methods are ready in a reproducible way. So I hope at the end, when I'll finally submit the paper, everything will be public on GitHub, and all the pipelines that I use, all the code, will use Nix, and Packrat is also a nice way to version control, to snapshot your R module. And if you're interested in any of this, you can ask me anything. I'm BNP Viera everywhere, so you can ping me on Twitter. And you can check some of the stuff we are doing at Wormlab. So if you will go to wormlab.github.io/tools, you can see some of the tools me and other people in my supervisor lab have been working on. And I think that's it.
Great. So I've put a question under line 93, and I think there's one other question that's coming in. Bruno, do you want to answer those questions? The first one is, go ahead.
Yep.
So the first one is, did you have any trouble getting your lab or institution to let you share all these resources and data?
I didn't have any issues from the institution or the lab, because I think when I went to this group, my group was already very open. So my supervisor already did things very open. We sometimes have some issues that because we work in a small niche field, and there's just a few labs doing the same research as us. There's a lot of competition, and so sometimes I cannot release immediately the stuff I do until it's published, which really annoys me. But it's only the major thing. If it's not something directly related to the research, or if it's not something that might compromise our results before they publish, we just release everything, and we try to be as open as possible. Yeah. So there's another question: what package did I use to get a snapshot of our package? So it's called Packrat. It's a 985 because usually the way I do things is I use Nix to install the language like R, Python, and all the things. So that's why it's version and it's not relying on the OS. But then to install the libraries for each language, I usually just use their own package manager. So if I'm doing NPM, if I'm doing Node.js, I use NPM. And in NPM, it's very easy to track your versions on your modules. But in R, it's very difficult. R doesn't have an easy way to keep track of everything you installed and then move that to another machine and make sure it works. And so with Packrat, that kind of solves that problem. So you just install whatever you need in a folder, and then you install Packrat as a R module, and then it will detect that which modules you're using. And so then you do like a packrat snapshot, and you'll store inside that project everything you used, all the R modules. And then if you copy that folder to another machine and you try to run it, if for some reason the modules you installed are broken in the other machine, packrat will just reinstall what's needed. But it keeps the source code and the binaries, and then so you can actually include the source code in your Git versioning. And so in that way you're sure that you always have the code that you use to do the analysis. So you don't, so it's a nice way, I think, to keep versioning our modules.
Great. Thank you so much, Bruno. We're going to move on, and Joey Lee is here. He's a former Mozilla Fellow for Science. Joey, do you just want to say a couple words to introduce yourself and then talk about your open science stuff?
Yeah, sure. Hi, everybody. It's been a long time, so it's great to see all of your beautiful faces. I, like Zana said, was a former Mozilla Science Fellow. I'm sad that that it just didn't last forever. Here I am. I'm in Germany now at a little research lab group called Mobile Lab, and they do kind of weird experimental projects on the future of urban mobility. Basically, that could mean kind of spooky videos or kind of interesting product concepts or whatever, like designing things. So trying to figure all that out at the moment, but on to open science. Yeah, so I guess in between my day job, I guess I'm still working on the BC Climate Explorer, which is a project I worked on during my fellowship. We have kind of the old website and like our old repo, but the idea is to kind of refactor all of the code and make a structure that is more modular, so we can add more functions to it. And we also had some discussions on our side, and I think right now the website is like kind of confused. Like on one hand, it wants to be kind of a communication piece, which communicates all this like climate data that we have, but then you have all these like complex charts that like kind of the normal public might have trouble understanding. So what we decided to do is kind of transform the BC Climate Explorer into two parts. So first, this tool for maybe the more science-y audience, or maybe the informed public would be happy to use, and then to be more like a public-facing communication project. But the first trick is to kind of make this tool that we can kind of gain insights and then build a story around that. So with the help of Kevin Krugman, I guess he's not here, but he is a student at the University of Applied Science in Weingarten, which is a small city in southern Germany. I did kind of a presentation at the university, and he just like came up to me and was like, "Hey, this is really cool. Would love to get involved with Mozilla Science. How can I do this?" And then I was like, "Yes, this is excellent. I have kind of a person who's created coding and been helping me through this project." So I'll last out him in, I guess. Yeah, he is super excited and really helpful. So that is going on. I'm also needing to get some documentation and stuff for the GeoSandbox, which is kind of a compilation of lessons on how to learn all of these new web mapping libraries, and the idea is to kind of break down each function that you might use, like how do I draw a circle on a map, and have it be like a really simple line of code that you can then copy and paste into your projects, and so on. So I need to kind of do a bit of work on that, of course. And I have paper review today, so we submitted my master's thesis work to an open source journal and our open access journal, and the reviews are due today, so I will be doing that after this call. So there's a question. Why a new repo versus making changes just to make? So that is a great question. yes, ideally we'd keep everything in one place, but I guess just for the sake of starting fresh, we decided to start a new repo. That is probably like the worst reason to, but I guess for the sake of making it easier for us, we just decided to start a new repo. Yeah.
So Joey, just a quick question. Can you give an overview of the Climate Explorer and what it does? It's great to hear the project status, but I don't know if I quite caught the big picture of it. And actually, if you'd like to screen share and just demo it, that would be fine if you're up for it.
Yeah, this is pressure's on. Let's open a session and screen share. Yes, there is the screen. Okay, excellent. Cool. So, good. um, so in a second, there'll be some map tiles that will load, but you can just imagine that they're there for now. So this is the BC Climate Explorer version 001, and it is an app or a website that allows you to explore all of the climate data for British Columbia. There's all of these sort of climate zones that are used in forestry and for ecological modeling, trying to understand what these various ecosystems kind of like fall into, or what categories they fall into. And so you can kind of click on these different buttons and they reveal like how much diversity there is, even in which one province. And yeah, we can also like toggle these various climate variables. So there's like mean annual temperature, the extreme minimum temperature over 30 years, and there's like all this stuff. But the coolest part are like these graphs. And so what you can do is kind of place like a marker, let's say right there. Let's start using that. Yeah, so optimization is key at some point. So let's say we're going to make another marker. Oops. Things are yeah, so live demos are always interesting. But anyways, what you can see is kind of the change of these various variables over time. And the coolest thing, I guess, when the thing doesn't break, is that we can see kind of projections into the future. So let's go now into here. Over here you can see that the mean annual temperature is projected to rise quite substantially for this particular region. And yeah, so that's like one aspect. And the other thing is that you can also see where the two various climate variables are at the moment, and in the future where they might go. So kind of this area here, highlight that thing, will start to look a lot more like that thing over there. So you can start to get a picture of where the climates are now and where they will go in the next 70 years or 40 years, I guess. Yeah, so that's kind of the idea behind the tool. And you can see that there are some things that need to be changed. So here we are.
Thanks, Joey. That's terrific. What I think I really love about this tool also is it just makes the climate data available to so many different kinds of people, not just scientists, but also citizens and foresters and anyone who's living in the area. So I particularly really love this tool. I think we answered Joey's questions under the under line 108, but if you have any more that occur to you, please type them in there and check out all of Joey's links. The next little bit here for the rest of the meeting, we're just going to do a sort of quiet, silent ether padding discussion and Q&A, just to get a sense of what open science is like where you are, where you're working, where your study group is based. So I want to invite you guys for just the next maybe 5 or 6 minutes to silently etherpad under line 113. Just type your answers. How is open science viewed at your institution and in your lab? What practices that you've learned about might be most easily adopted? What are your biggest blockers? What are challenges you often hear to open practices, and what are your own concerns and hesitations? And then for all of us together to think about what could remove the blockers, what are responses to challenges that you're seeing above or ones that you've used yourself. So inviting you guys to just spend the next, let's say, maybe 5 or 6 minutes just typing in here, and then we'll talk a little bit together at the end. Sound good? Great. Let's go. Okay, so lots of awesome stuff still coming into the pad. Um, and I'm seeing also great, a lot of stuff from Bianca Kramer. Bianca, do you want to just verbalize really quickly what your institution is doing or has done that seems to be generating so much activity?
Well, it's really two things. It has not, what the university is doing has not generated so much activity, but at least in their strategic plan, they've stated really bold ambitions. So we are now, I work at the library, and we are now really seeing, okay, how can we use that, how can we leverage that to really get open science on the agenda, not only as an ambition, but really put it into practice, and talk about it with researchers, and see what role we can play. So we see that as an opportunity, and I don't really see that currently that our university or the Netherlands in itself is already so much front runner, but at least they have the ambitions.
Mm-hmm. Where did the ambitions come from? Like, what was who was it a top-down decision, or where did the yeah?
Yeah.
So somebody.
Which are these conversations? Okay, when you say you want to be front runner in open science, what do you think open science means? What do you feel that means? And well, take it from there.
Great. And I just want to point out that there's lots of stuff that Bianca's put under line 26, and everything that people are putting under line 123 is really powerful there, so be sure to check those out. Let's see. Competition seems to be a pretty big factor. I know that people have mentioned the tenure and publishing sort of requirements, tenure and promotion requirements that focus on publishing. And I think it's actually not shared here, but I will be sure to put it in under line 163, just right after the meeting ends. But I know that Oregon State University has been starting to modify their tenure and promotion requirements to include more open science activities. So that's one way to at least help get around that problem of that people aren't rewarded for these really positive activities. They're sometimes penalized for them. So sort of looking at institutional and policy change around those requirements is really important. And I think under line 64, it's a grant requirement in the U.S. and I think in European countries, when public funds are given for research, there's often a requirement that the results be open. And so that is really, really powerful as a motivator. People know that they at least have to do something to make things open. So I think that's a really powerful motivator as well. Lots of things still coming into the pad. So I don't know if anyone else wants to call anything out in particular. But I think the other take home that I want to mention here is just that I think your study groups, which are forming now, are really great places to sort of explore all these ideas. I think people often come to the study group because they're motivated to learn a skill that they need for their research, but they haven't yet acquired. And so people may come to the study group with just sort of that motivation to improve their own research, but it's a really, really great place to begin to get them thinking beyond their own work and maybe their own career and thinking about working more collaboratively, learning some of these skills, how data and knowledge can be shared, how practices like code review can begin to encourage people to think about working a bit more openly as a really positive and not scary thing to do. And the study groups are a great space to do that. So I want to thank you guys all for thinking about and starting your own study groups, and appreciate that that's like a first step for solving at least some of these problems or having these conversations. So I also love underline 161. I know it's been said before, but embarrassment about my code still plagues me. Who wrote that? Is that Madeline? Do you want to say a little bit about that?
So, I mean, this is a thing that I've really terrible idea of how to do that. So I think you kind of have to be willing to, yeah, be open-minded about that kind of stuff.
Right. And I think definitely having the study group as a space to have those discussions and sort of learn together to code may get you more used to looking at code with other people and get you more comfortable in maybe defending your ideas or taking suggestions or criticism. So I totally appreciate that. Like, we're not all super coders, so making the study group a welcoming place or a place where these kind of discussions can happen in a more organic, gentle way is really important. So I want to encourage you guys all to keep adding things to this pad, and I'm super excited to see this like rainbow of ideas and suggestions that have come up during this last little part. If you are excited about a conversation or an idea you see here, I welcome you to take it to the Gitter chat and keep talking about it. We're out of time now, but the last thing I want to highlight is that our next meeting is going to be a group meeting on February 3rd. The meeting time is 11 a.m. Eastern time. I'm not sure what that translates into UTC, but I'll try to put that information here under line 179. Hope to see you all there. It's a big joint meeting with all the study groups, and it's the last video call that we'll be doing for this this orientation session. The next time we meet, it'll be online in the Gitter chat to check in on all your study groups. And in the meantime, I'll be sending out a survey to find out if there's anything more that you feel like you want to know or learn about running a study group. And finally, I should say that the next meeting, that joint meeting, the study group learning call on February 3rd, we're going to talk about growing your group and building community. And then we're also going to go over sort of a study group lesson, sort of run through what does it look like to give a lesson or do a workshop in a study group setting. So you'll get some a better glimpse at teaching and facilitation in the context of study groups. So thank you guys all for joining the call. Feel free to jump on the Gitter chat if you have questions. And I think that's it for today. Thanks to all our guests, Bruno, Joey, and Peter and Madeline. Thank you so much. And have a good Wednesday, everybody. Bye.